Right, so now I'm going to start on lecture 10, Monopoly. This is just the first, this video is just for the first page. So a monopolist is just the sole supplier of, for the market. So they're the only firm that is selling a particular good. And what this means, right, is, if you're the only firm that's selling a particular good, this means that you're also able to set the exact market quantity, right? They can choose exactly how much to sell. All right, and it also then, as we'll see, means that they can set prices. Now, as we'll talk about, there's going to be some limits to what prices they will want to set, but they do have the ability to charge whatever price they want, and we'll talk about that more. So the one thing that I want to make clear, I think in this part is that, or in this first sort of page of the notes, is that our model is really an extreme version of what we think of for monopolies. So just like perfect competition, where we thought about this world in which firms had absolutely no market power and had to price at exactly marginal cost. That was one extreme case. Monopoly is another extreme case. In this case, there's going to be exactly no competition whatsoever. And I'll talk in a moment about why that is maybe not realistic. And firms don't worry about the entry of competing firms. So the idea of no competition at all, and why is that a really extreme case? Well, it turns out that most products have some competition, right? So 10 years ago, right, cable TV, right, really didn't have a whole lot of competition. You had one supplier in your market, but there are still things that you might think of as sort of competing products, right? So maybe satellite TV, maybe radio, or going outside were competitors, or reading books. Right, and so even then, when we have something like a standard monopoly, right, there's still a way to compete, right? Or phones, right, is another sort of standard monopoly case. At least 20 years ago, when we all had wired phones, but people could still talk to each other in person or write letters. So this idea of no competition is not something very common. Probably the water utility might be the closest we can get. Though even then, if the price of water goes up, maybe we drink soda. I don't know how we wash things though. And then the other part of this, and this is again just in terms of the model that we're going to write down, you'll see that we don't worry about potential entry of other firms. So that's just not going to be something that's constraining our firm. When do we see firms worry about potential entry? Well, one case, and I've given this a lot of, I've talked a lot about oil markets. So not now, but 5 or 6 years ago, there was we were in another world where oil prices were very low because OPEC was wanting to keep prices low because they wanted to avoid US shale producers from basically drilling wells, right? Because once they do that, those firms are going to produce more oil, and it's going to lower the price that OPEC producers are able to get, right? And so what they were doing is they were holding their prices low right? Because they're worried about US potential entry, okay? And so they're not acting exactly like a monopolist, right? There's some competition that may or may not really exist yet that they're worried about, okay? And we're not going to be thinking about this in our models, all right? The other, I guess, point that I make in this first page of the lectures is why do monopolies exist? So what are some reasons for monopoly? And again, like these reasons are, not like as extreme as sort of the model that we're going to be working with in our class. So we might have firms that have like increasing returns. So, either firms that have high fixed costs or just firms where, operating on a large scale makes you more efficient. So this might be something, like a Boeing, right, where like only so many companies have the scale to like make airline parts. Another situation, might be like utilities, right, where these firms, once you've laid down all of the lines, right, you've paid extremely high fixed costs. There isn't really a value to like having a second firm in the market. Another reason that we might have a monopoly is, if somebody has access to an input, right? So we see this a lot in like oil and mining, where maybe it's not a firm, but like a particular country is the only one that's able to do something because they're the only ones who can access this input in the ground. Network externalities are becoming sort of a more thought of reason that we have monopolies. So a network externality is a situation where the firm gets value based on how many people use their product. So a good example of this might be like Facebook, where because your friends are on Facebook, right, you want to be on Facebook, and therefore it's like way more valuable than some other social media site where like your friends aren't on it, right? You don't want to be on that site, so there's no value. And so these types of like social media industries tend to monopolize very quickly because you want to be on places that your friends are. And then finally, and probably the most common, is legal barriers. So we might think of patents where the government says you're the only firm that gets to produce this product for a certain number of years. That's a very common legal barrier. It doesn't necessarily have to be the government that provides a legal barrier. So sometimes you get like licensing restrictions. Various industries, hairstylists, I think even like lawyers and doctors, right, will have firms that say, you can call yourself a hairstylist, or you can call yourself a lawyer, or they have organizations that do this, right? So like American Medical Association, the American Bar Association, will basically say, you pass the bar, right? You can practice the law in our state, right? And these are like legal barriers that restrict entry into the practice of law, or and these occur in other industries as well. All right, so now I'm going to talk about the monopoly and marginal revenue section, which starts basically, I guess, page 1, but it's mostly page 2 of the notes. And so the main goal here is really to just get a sense for like why marginal revenue is, or what the revenue function is. And that's going to require basically understanding what an inverse demand curve is, and then I'm going to talk about uniform pricing, which is sort of the key assumption for how we're going to model monopolists. Okay, so the idea here, right, is that the monopolist, because they're the sole supplier, monopolist chooses market quantity. And the quantity decision sets the market price. Okay, and so basically we can think of the monopolist doing this either way, right? We can think of them choosing quantity, right? Or we can think of them choosing price. And sometimes it's going to be easier just to think of the monopolist working with quantity. And the reason for this is because marginal costs are going to be a function of Q, like they have been, in the perfect competition as well. And so when we write down our profit function, right, we're going to want to think of the monopolist choosing quantity because that's what their costs are going to be. But to think of this, I guess, graphically, like why can we think of what do I mean by the monopolist can choose either? And right, so we have a demand curve, right? So let's say QD is our demand curve. The monopolist can either choose, right, or basically with the demand curve, right, for a given price. Let's say we have price P1, right? We go to the demand curve and we realize, okay, at price P1, quantity demanded, or the amount that consumers will demand, is the quantity Q1, right? At price, say, I don't know, P2, right, the quantity that consumers are going to demand is Q2. Okay, and the monopolist could either choose, what if I just choose Q1, right, and that's going to set a market price of P1, right, or if I set a quantity of Q2, that's going to set a market price of P2, right? So the monopolist can choose either one. Okay, so it's actually going to be easier for us. So what the monopolist is doing when they set a quantity, or when they're choosing quantity, this is technically an inverse demand curve. Right, so an example of this might be like P of Q is equal to 100 minus Q, okay? But the idea is the same, right? The monopolist chooses a quantity, right, rather than a price, and that quantity tells us what the price is, right? So let's say the quantity here is, quantity 1 is 25, right? Well, then our inverse demand curve, right, tells us that the price should be 75. Right? Or if the quantity 2 is 50, right, then the inverse demand curve tells us that the price that will sell 50 units is 50. Right? So that's all, that's all I mean when I say, this is an inverse demand curve. Okay. And again, right, this is, the same decision, right? The monopolist could choose a price of 75 if it wanted to sell a quantity of 25. But this is all the same, on the graph it looks the same. It's just we want to write it as a function of Q, right, so that we can work with marginal cost curves as a function of Q. All right. So there's one sort of big assumption that we're going to make in this lecture, which is that the monopolist has to sell all units at the same price, which is what we call uniform pricing. All right, and this is, like we're used to seeing this where everything, when we go to the grocery store and we see, a box of cereal, right? Every single one of those boxes is sold at the same price, right? Or if you go to the gas station, every gallon that every single person purchases on that day is sold at the same price. So this shouldn't feel like too big of an assumption, right? But in the next lecture, just to sort of give the counterexample, right, to this assumption, we're going to think of situations where firms can charge different prices to different people. Like a car dealership, where you negotiate the price of the car, right, with each individual buyer, or the car salesman negotiates the price of the car with each individual buyer. That would be a situation where the uniform pricing assumption is violated. Another assumption that we'll see is like movie theaters, right, which will charge different prices for like students and seniors, right? So that wouldn't be uniform pricing. But we'll talk about that in another lecture. Okay, so for now, right, we're going to assume uniform pricing. So the monopolist has to sell all of their units at the same price, right? Which means that there's one market price. Right, and that our market price is going to be basically the one that the monopolist sets. All right, and what this will get us, and we'll see this when we do price discrimination, where we'll have firms charging different prices. This will be different, but for now, right, the fact that we have one market price means that we can write down a revenue function as just price times quantity, right? So as before, revenue is just price times quantity. Right, like in perfect competition. But the difference now, right, is that price is a function of quantity. All right, and yeah, so this function basically tells us how much revenue the firm will get, right, if it sells Q units. So just to give an example of a revenue function here, so with our inverse demand curve of P is equal to 100 minus Q, the associated revenue function might be, or the associated revenue function would be RQ is equal to PQ times Q, right, which is equal to 100 minus Q times Q, or just 100Q minus Q squared. Okay. So in this case, if the monopolist, say, produced 10 units, right, it could sell that for 900, it would get 900 units of output, because the price would be 90 times 10 units. If it produced 20 units, right, it would get $80 per, the market price that would sell those 20 units would be $80, right, and then it could sell those 20 units, and so it would get 1,600 units of revenue, or $1,600 of revenue. Okay. So marginal revenue then. Is just the derivative of the revenue function. All right, so I'm going to write it in general terms first. So marginal revenue is equal to the derivative of revenue with respect to Q, which is with the product rule, right? The derivative of Q, or of the inverse demand curve times Q, right? Plus, so the derivative of the first times the second plus the derivative of the second times the first, which is just PQ. All right, that's the product rule is how we get that. Okay. So notice, right, that compared to what we were working with perfect competition, right, and we'll talk about this later, right, there's basically this extra term here, right? So with perfect competition, marginal revenue was equal to just P, right? Because price was not a function of quantity. Right now, marginal revenue is a little bit more complicated, and in I think 2 lectures, video lectures, we'll talk a little bit more about sort of what this implies. For now, let me just work through sort of an example, our example of what the marginal revenue curve is. So when P of Q, or when revenue is 100 minus Q squared, marginal revenue is equal to the derivative of revenue with respect to Q, which is 100 minus 2Q. Okay, so sort of one last point that I want to make here is, so I'm going to graph out basically the demand curve, or maybe the inverse demand curve, right? P of Q is equal to 100 minus Q, right? So this is our inverse demand curve, and then our marginal revenue curve is twice as steep. MR is equal to 100 minus 2Q. So this is something that I know that when I was in like undergrad in principles, I always saw these graphs, right, where marginal revenue is twice as steep as the demand curve. This is a like figment of the fact that we have linear demand. So and this is only true with linear demand. Right, because when we have linear demand, to get revenue, we multiply by Q, and then we have this squared term. When we, right, so this, you know, revenue is 100Q minus Q squared, and then when we take the derivative of that, we get rid of that Q, so the 100 stays there, right, but then we get 2Q. So just with linear demand, we're going to get marginal revenue curves that are twice as steep as with as the inverse demand curve. We're mostly going to be working with linear demand here, so we're going to see this a lot, So I want you to sort of be used to seeing it, but understand that it's a little bit of it's an assumption, or it's implication of an assumption that we're making. All right, so now lecture 10, profit maximization, which is on pages basically 3 to 5 of the lecture notes. The goal here, so first of all, like the takeaway that I'm just going to repeat again and again and again for the rest of the semester, like what we're doing for the rest of the semester is write down the profit function, take the first order condition. We're going to do that here. The one other thing that maybe I want us to be aware of or know how to think about is how to draw the graph for the monopoly price setting and what that graph looks like. So again, the goal for the monopolist is to maximize profit, and I guess that's an assumption. And the way that we're gonna, and like I said, right, what the thing we're gonna do is we're gonna write down the profit function, right? Profit, right? Always, always, always revenue minus costs, right? The thing that we do differently from perfect competition is that in this case, the revenue function is different, and we talked about that in the last video lecture. Okay, so I want to do this more generally first. So let's just take the derivative of this without giving you a functional form for revenue and cost. So the derivative of profit, right, with respect to Q is basically marginal revenue minus marginal cost. We set equal to 0, right, which implies that marginal revenue is equal to marginal cost. Okay, so we've seen this before, right? This was the general condition for profit maximization, right? Marginal revenue equals marginal cost is always going to be true, regardless of the market structure, right? Perfect competition or monopoly, or when we have duopoly, whatever. This is always going to be true. And we can think about again why, right? So if marginal revenue was less than marginal cost, right, then that last unit, right, the firm is losing money because they're getting less revenue than it costs to produce, and so they should produce less, right? If marginal revenue is higher, right, than marginal cost, well, the firm is making money by producing that last unit of output because the revenue is higher than the cost, so they should produce that unit of output and maybe more. It's only going to be when marginal revenue equals marginal cost, right, that the firm is maximizing profit. Right? If they're producing, if marginal revenue is higher, they should produce more. If marginal revenue is lower than marginal cost, they should produce less. Okay? So what I want to do then, right, is draw the graph for monopoly price setting. So what does this look like before I give a numerical example? So what we had before, right, in the last lecture, is we had an inverse demand curve, all right, and then we had a marginal revenue curve, which I said is when we have linear demand is twice as steep as the revenue curve, and then we have some marginal cost curve. Say it looks like that. All right, so when the firm, right, is profit maximizing, what it's going to do is it's going to take its first order condition with respect to profit, right, or sorry, with respect to quantity, right? So it's choosing a quantity that sets marginal revenue equal to marginal cost. And so graphically, right, what that looks like is that it's choosing, right, this quantity here. Let's call this Q star, right? So the firm, right, chooses quantity, right, such that marginal revenue is equal to the marginal cost. Okay, and then, right, we need to figure out, well, what price does the firm sell this quantity at, right? And so I think a lot of people look at this as this price, right? But that's not quite right, right? The firm, when it produces this amount of output, right, can then sell it at this price because this is the demand curve, right? This price here, let's call this P star, or I guess I should call this like PM. The monopolist price, right? At this price, the demand curve tells us how much people want to consume, right? So we have to plug in Q star into the inverse demand curve to figure out the price that will sell QM or Q star units. So what I say here is we need to sort of walk up to the inverse demand curve. From Q star, right? That tells us how the price that will sell Q star units. All right. So, and just to make this, I guess, clear, right, before, right, what we were doing is we're setting the market price equal to marginal cost, right? So that was going to give us a market price, right, that would clear the market, right, of here, where the actual demand curve hits the marginal cost curve, right? That's going to be the perfectly competitive price. So I'm going to call that P comp, right? And this is going to be the perfectly competitive quantity Q comp, right? But because we have a monopolist, right, they're setting marginal revenue equal to marginal cost, which, but their revenue curve looks different because they can change the market price as they change revenue, which as they change quantity, which I'll talk about next in the next lecture. The monopolist will produce less, and the graph, looks like this. So let's work through an example problem of this. Okay, so I'm going to start by working through the example on page 4 of the lecture notes without solutions. So there, what I give you is I give you a demand curve, not an inverse demand curve, of 280 minus 4p, cost function of 35q, and what we're asked to do is let's find the profit maximizing price and quantity, and then at this price and quantity, what are the monopolist profits? All right, so the first thing that I do, and just I guess because we solve out for when we do demand, we solve for a demand curve, not an inverse demand curve. The first thing we need to do is just make sure that we have an inverse demand curve. Okay, and how do we do that? Right, well, we just need to write down the demand curve and then solve for P. All right, so Q is equal to 280 minus 4P. Adding P to both sides, or 4P to both sides, and subtracting Q from both sides, we get 4P is equal to 280 minus Q. Dividing both sides by 4, we get P is equal to 70 minus Q over 4. All right, and working with an inverse demand curve is helpful because costs are a function of Q as well, and so we can just write down the profit function and then take our first order condition. Okay, so that's exactly what we're going to do. So I think in the notes I have this as 2 steps. So step 2, write down the profit function. And so profit is always equal to revenue times cost, or revenue minus cost. Right, always. With a monopolist, revenue is P of Q, right, times Q minus cost, which in this case is 70 minus Q over 4 times Q minus 35Q, or 70Q minus Q squared over 4 minus 35Q, or, if we're going to go through this all, this is 35Q minus Q squared over 4. Okay, it might be helpful. Oh, yeah. So then what we want to do is take the first order condition. Right, so again, what we're trying to find, right, we're trying to maximize profit. So let's find the point on the profit function where the slope is equal to 0. Right, and to do that, we're going to take the derivative and set that equal to 0. So this is 35 is equal to 2Q over 4, right? Or 35 minus 2Q over 4 is equal to 0, or 35 minus Q over 2 is equal to 0, right? Solving for Q, we're going to add Q over 2 to both sides, multiply both sides by 2. We get QM is equal to 70, right? And so if we're going to draw our little handy graph here, right, we have a marginal cost curve here at 35. Right. We have an inverse demand curve of 70 minus Q over 4. And then we have our marginal revenue curve. And our marginal revenue curve hits marginal cost at 70 units. That's when marginal revenue is equal to marginal cost. Now we need to find the price, and to do that, what we're going to do is walk up from the quantity of 70 up to the inverse demand curve, and we're going to find the price that will sell 70 units. So step 3, basically, we're going to plug QM into inverse demand curve. to find the price. All right. And so to do that, our inverse demand curve here is 70 minus Q over 4. Plugging in 70, we get PM is equal to 52.5. All right, and then from there, just to find profits, which was like the last thing that we asked for, to find monopolist profits, we can just plug that into our profit function, right, which is now P times Q, PM times QM, minus C of QM, right, which is equal to 52.5 times 70 minus 35 times 70, right, which is equal to 1,225. All right, so now I'm going to talk about the section trade-off from raising prices, which is page 6 of the lecture notes. And really the question, the main question that I want to get at in this video is why does a monopolist set the price above marginal cost? And basically, what are the trade-offs from raising prices? So for a price-setting monopolist, recall that we can write demand as either or revenue as price times quantity, and we can either think of the monopolist setting the price or setting the quantity. So if we think about the monopolist setting the price, then we have the price that they set is their revenue times the actual demand curve, right? So before we had like an inverse demand curve times quantity, now we're just saying it sets price, and so it has a revenue function that looks like this, okay? And this is going to make it a little bit easier to think about why the monopolist sets the price that it does. So if this is our revenue curve, okay, then marginal revenue, right, we're going to be thinking of, the firm setting marginal revenue equal to marginal cost, right? But marginal revenue is the derivative of revenue, in this case with respect to price. All right, and so using the product rule, right, so we get basically the second term times the derivative of the first, so just QP, plus the first times the derivative of the second, which is P times the derivative of Q with respect to P, okay? And so the first term, right, says that if the monopolist increases its price by $1, right, then for each additional, or for each sale that the monopolist continues to make, right, it gets that dollar, right? So revenue goes up by QP. Right, so I'm going to draw a graph, show this point here. So we have some initial here, demand curve. We have some initial price and some initial quantity. So let me call this QP and just P. All right, the price goes up by $1. So we go to P plus 1. Okay. Now, for all of these sales here, right, the monopolist is making an extra $1 for those sales, which is roughly, so in sort of the limit terms, right, or in terms of like a derivative, they're making they're making QP plus 1, but in the limit, as the change gets small, so as we make this less than $1, right, in the limit it's just QP, because this area here converges to each other, okay? So that's sort of the first thing, right? The monopolist, as it raises its prices, it gets more money from all of the sales that it already makes, okay? But, right, there's the second term, right, which says that demand falls. Right, the monopolist loses some sales. How many sales do they lose? Well, they lose the derivative of Q with respect to P, right? This tells us as P goes up by a little bit, how many sales go away, right? And so that tells us the width of this rectangle here, right? If you were to, so in the graph, if you were to increase price by $1, you lose this many sales, right? And then how much revenue is lost? Well, the amount of revenue that's lost is the number of sales that you lose times the price. Okay, so that's this area here is the total revenue. Okay, so just to summarize this point, right, when the monopolist wants to raise the price, right, if the monopolist wants to raise its price, there's a trade-off, right? Raising prices does two things. Right, so one, it increases revenue from sales that continue to be made. Right, but it decreases revenue from lost sales. And that's, so one is this area here, and two is this area here. And so as we'll see, right, depending on how quickly revenue falls, right, is gonna basically, that's gonna be what constrains the monopolist to be setting a lower price, right, or, you know, the price, you know, this is going to keep it from setting like a very, very, very high price, right? Whereas this is going to tell the monopolist or incentivize the monopolist to, the first reason, you know, increasing revenue from sales that continue to be made is what is going to incentivize the monopolist to set a price above marginal cost? All right, so now I'm going to talk about the section monopoly markup, which is page 7 of lecture 10. Just recall really briefly, right, in the last section, we talked about the trade-off from raising prices, and this is when the firm has a uniform price, right? The trade-off here is just that when they raise the price, they get extra money from those sales that continue to happen, right, but lose money from lost sales, right? So when consumers go away. And so it turns out, right, that how quickly a consumer loses, or sorry, how quickly the monopolist loses customers, right, is sort of fundamental to what price it will charge, okay? And, or what the markup will be, right, where just the term markup is just the difference between price and marginal cost, okay? So what we'll show in this lecture is that the markup depends basically on the elasticity of demand, or how sensitive the quantity sold, right, is to the change in the price, okay? So intuitively, right, if you just want to think about like what the firm should do, right, if the firm was selling 100 units, and if a firm could sell 100 units at like $200, right, but if it could raise the price to say $500 and only sell one fewer unit, like clearly that's profitable, right? It would be getting a lot more money, right, from the consumers who are still purchasing, and it's only losing one sale, right? And so it's not, the trade-off here is that it's not losing very many sales, but getting a lot of money for additional sales, so it should set a very high markup, right? And that's going to be the case, right, when demand is very inelastic, right? So they increase prices by a lot, quantity falls by very little, and that's shown in this first graph here, right? The inelastic markup, right? The firm can raise prices by a lot, so from here to here, right? And quantity falls very little, okay? If that's the case, the firm should have a large markup, right? If demand is very elastic, right? So if going from 100 units at $200 to say 50 units at $201, so the firm raises its price by $1 and half of its demand leaves, right? That's going to be very elastic demand, right? Which means that this part, like this part of the trade-off, right, is very big compared to this part, right? Here we only added $1. Here we lost half of sales, okay? So in that case, right, the firm shouldn't, it will be costly for the firm to raise prices, right? And so they're not going to raise prices a whole lot. And that's shown on the right panel here, right, where raising prices a little bit, right, changes the quantity for the firm quite a lot. And so just like intuitively, right, the point that I'm trying to make is that the elasticity of demand affects the markup that the monopolist should charge. So I'm not going to make you responsible for the algebra here, but I do want to just show you that, if you want to, you can work through it yourself, right? So what we do here is, start off with the idea of profit maximization, that a monopolist, when maximizing his profit, right, sets marginal revenue equal to marginal cost, right? We can sort of work through sort of that formula and basically just, doing algebra, get to this formula here, okay? P minus MC is the markup. It's the difference between price and marginal cost, right? So I guess this is like the percentage change in markup is equal to 1 over the elasticity of demand, right? So this is the formula that says that, when demand is more elastic, the firm should have, right, a lower markup. When demand is inelastic, right, so this number here is small, right, this firm should have a much
larger markup because this is going to be a larger number. Okay. The other, I guess, takeaway from here, right, is that the monopolist will always operate on the inelastic, on the elastic portion of the demand curve, right? And intuitively, right, it's because if demand is inelastic, the monopolist should raise the price, right? It's profitable to raise prices because you're not losing that many consumers, right? And so if demand is inelastic, the monopolist will raise the price until they get to a point, right, where demand is elastic, right? Once they've raised prices enough, right, which will then make it unprofitable to raise prices. So takeaway here, right? The monopolist always operates on the elastic portion of the demand curve. It does this because, Anyway, so takeaway from this lecture, right? The greater the elasticity of demand, right, the smaller the monopoly markup. We showed this graphically, we showed this algebraically. Just to put this into perspective, right? When we thought about like perfect competition, right? The way that I described perfect competition was that a firm, if it raised its price by like a cent, right? All of the consumers would go to like the neighboring firm. So I think we were at like a farmer's market, maybe selling like corn or apples or something, right? And the idea was, these products are homogeneous, right? So, they're the same thing. And so, charging 1 cent higher than, the store next door, right, was going to let all of your demand leave. And that forced these firms to price at exactly marginal cost, right? Because if they raised their price anything above that, somebody would undercut them and it would be profitable for them to do that, right? So we can get that result here, right, by thinking about, well, what would happen, right, if demand was infinitely elastic, right? Well, it turns out in that case, if we put infinity into the, in the limit, into the denominator of this fraction, right, there's no markup, right, which is exactly what this tells us. So the way that we can sort of think about this in the homogeneous products case, right, it wasn't that the market demand was infinitely elastic, right? We had a market demand curve when we did perfect competition that was not infinitely elastic, right? But product homogeneity made it that the demand curve that a firm faces, not the market demand curve, but what the firm is facing when they change their price is infinitely elastic, because if they raise their price by a cent, all of their demand leaves, okay? It's the same idea with the monopolist, right? It's just that the monopolist doesn't have a competing firm here, so they are able to raise their price because, what else are their consumers going to go to, right? It's like they're just not going to purchase the product, but there's not somebody next door selling the same thing. And that's why the monopolist is able to price off of the entire demand curve, not just, the firm-specific demand curve that was limiting in perfect competition.
All right, so lecture 10, monopoly and efficiency, which is pages 8 through 11. I'm gonna, just to review, right, the monopolist, when it set its price, right, how it sets price is it set marginal revenue equal to marginal cost, and then it walked up, and that's how it set its quantity. And then from there, what we did is we walked up to the demand curve to get the price that the monopolist set, all right? And this price is higher than the price that would be charged under perfect competition, right? Under perfect competition, price is equal to marginal cost, which is here, right? And so we have the perfectly competitive price and we have the monopolist price, okay? So the monopolist is, pricing above marginal cost, and it is producing right, less than the than would be produced under perfect competition, right? And so that suggests that there might be some lost total surplus because quantity is lower. All right. So the monopolist quantity is less than the perfectly competitive quantity, right? Which suggests total surplus is lower. Because sales are lower. And in particular, right, there are people who are willing to pay, so this amount here is sold under monopoly, right? But there are people, say here, who have valuations that are above marginal cost, right? Where those sales are not being made, right? So if somebody, let's say that the price here was 50 and the marginal cost here is like 20, right? There's 30 units of surplus to be made here, right? But because the monopolist, right, doesn't want to raise its prices more, right? There's that trade-off between raising prices and losing sales, right? So because of uniform pricing, right, the monopolist won't create those units, and so it won't sell those products, and so that surplus that could be had goes away. So because of uniform pricing, right, monopolist charges a higher price, or monopolist reduces quantity, so some positive surplus trades do not get made. Right, resulting in deadweight loss. Okay. And again, right, the reason, right, for deadweight loss, right, is because of uniform pricing, right? The monopolist has to mark down or reduce the price on all inframarginal units, right, to sell more. Right, which reduces the incentive, right, to reduce prices. And this is entirely due to the uniform pricing assumption. So in the next lecture, lecture 11, right, we'll talk about what happens if you have a monopolist where they're not constrained to uniform pricing, and we'll see that the deadweight loss goes away. That it's not necessarily due to like the monopolist charging higher prices. It's really due to the fact that they have to mark down these inframarginal units. So what this suggests, though, right, is we have some deadweight loss, right? And I guess I should draw out. So the deadweight loss is going to be all of these units, right, where there are positive sales that could happen, right, where the willingness to pay is above the marginal cost. Right, all of these units that could be sold but are not, or where there would be positive gains from trade, that's where the deadweight loss is, right? Because so there's deadweight loss from monopoly, Now, often you'll hear people talk, or pundits or whatever, talk about how, or politicians talk about, how monopolies are making too much profit, right? And it's not necessarily that they're making too much profit that we're concerned about. What we're really concerned about is the deadweight loss, right? Because this is, if we, and in particular, right, the fact that quantity is being reduced, right? There are positive surplus trades that could happen, there are not, because this firm has market power, right? And so if we could change, right, whether or not they have market power, right, we could change to getting a higher surplus amount. But that doesn't necessarily correspond, right, to whether or not firms have profit, right? The profit in and of itself is not the problem, right? It's that the deadweight loss is the problem. That's what we worry about. So let's just go through an example now to see how to calculate out consumer producer surplus and deadweight loss. So using our numbers from before, so PQ is equal to 70 minus Q over 4. And C of Q was equal to 35Q. All right, and we want to find and so just to be clear, right, in this case, consumer surplus is the area now above the monopoly price and below the demand curve. Right. This is the price that consumers have to pay. This is their willingness to pay. The difference in that is their surplus. And the producer surplus is the area below the price that the monopolist gets and above their marginal cost curve. All right. So in lecture 10.3, we went through this example to find that the monopoly price was 52.5. We knew that marginal cost is 35, and we found the monopoly quantity, which was 70. So now when we want to find, I guess let's start with consumer surplus. The thing that we still need for consumer surplus is the P-intercept up here, right, to find the area of this triangle, right? So for consumer surplus, to find P-int, right, we're just going to set Q equal to 0 and figure out what P is. And that means that P is just equal to 70 in our demand curve. So we know now that this is 70, and now we have all the things that we need to find the area of this triangle, right? So for consumer surplus, the height of the triangle is 70 minus 52.5. The base of the triangle is 70. Times 1/2, which is 612.5. All right, to find producer surplus, right, we need to find the area between the price that the monopolist gets and their marginal cost, right, the area of this rectangle here. So we have all of the things that we need. The base is 52.5 minus the height of 35. And sorry, minus 52.5 minus 35, and the base is just 70, right? 70 units. And this isn't a triangle, it's a rectangle, so we don't multiply by 1/2, and this gives us 1,225. And then the final piece of this, we want to find deadweight loss, which is the area of this triangle here. All right, and we know the height of this triangle, it's 52.5 minus 35. What we need though is we need the base, and so we don't know this point here, but this is the point where price is equal to marginal cost, right? Or the point where the perfectly competitive market would produce. So for right, so to find the quantity, right, where price is equal to marginal cost, we can just use our inverse demand curve and solve for that. So using the inverse demand curve, we get PD of Q is equal to MC of Q. Right? Costs were 35, so marginal cost is equal, sorry, costs were 35Q, so marginal costs are equal to 35. And PD of Q is 70 minus Q over 4. And then solving for Q, we get Q over 4 is equal to 35, or Q is equal to 140. Okay, so we now know that this coordinate here on the Q axis is 140, and so we now know the base and the height of this triangle. Okay, so the base is 140 minus 70 times the height, which is 52.5 minus 35, and the triangle, so we multiply by 1/2, and this gives us a deadweight loss of 612.5. So after working through this, I guess if we were doing this in class, I would give a handout. And so if you want to work through another problem like this, you should take a look at handout H10 Monopoly handout. And this goes actually through the whole thing, so not just finding consumer and producer surplus, but also finding like what the price and quantity are. All right, so I'm going to do Monopoly handout H10. So here we have a demand curve 100 minus P and cost curve of 20Q. And the goal is to find the profit maximizing price, quantity, and then consumer surplus, producer surplus, and deadweight loss. So to start off with, the first thing that we want to do is we want to make sure that we're working with an inverse demand curve, because when we write down, what we ultimately want to do is write down a profit function, but that profit function is a function of Q, right? And this demand curve is not. So let's start by doing that. And to do that, all that we really have to do is just write down the demand curve and solve for P. So Q is equal to 100 minus P. Or P is equal to 100 minus Q. Okay, and then from there, we can write down the profit function. So that's going to be profit is P of Q times Q minus C of Q, which is 100 minus Q times Q minus 20Q and this is going to be 80Q minus Q squared. Okay. And from there, we want to take the first order condition. Right, always write down the profit function, take first order condition. So that's going to leave us with 80 minus 2Q is equal to 0. Or Q is equal to 40. All right. So what we just did is graphically QP marginal cost curve that is at 20. So we have an inverse demand curve, 100, P is equal to 100 minus Q, and a marginal revenue curve, MR is equal to 100 minus 2Q. All right, so what we just did is we just found this point here, right, which is where marginal revenue is equal to marginal cost, right? That's the profit maximizing quantity. Right now, what we want to do to get the monopolist price is we want to walk up to the demand curve to figure out, well, what price is going to sell 40 units of output, okay? And to do that, we're going to plug QM into inverse demand curve. To get PM. And so this is 40 into the inverse demand curve, which is 100 minus Q. And so PM is equal to 100 minus 40, which is equal to 60. All right. So from there, we want to find the consumer and producer surplus and deadweight loss. So let's start, I guess, with consumer surplus. And again, right, that's the area. So this is the actual price, 60. That's the area above the price and below the demand curve, right? So we want to find this area here up to 40, which is the quantity that's actually sold. To do that, right, what we need to do is find, so we know the base already, and what we need is the height, and so we need to find this point here, right? So to find CS, we need the P-intercept, right, which is what quantity, right, or what price makes quantity 0, so we can just plug 0 in for quantity into our demand curve, and we get P int is equal to 100. All right. So then for consumer surplus, we know that the height is 100 minus 60. We know that the base is 40 times 1/2 because it's a triangle, and we get 800. All right. for producer surplus, same idea. We want to find the area of this rectangle, the difference between the price that the monopolist is able to get for the products and the cost of producing times the quantity sold. So for producer surplus, we know the height of this rectangle is 60 minus 40, or sorry, 60 minus 20, which is 40, times the base of the rectangle, which is 40. And because it's a rectangle, we don't multiply by 1/2. And so this becomes 1600. And then finally, we want to find deadweight loss. And so deadweight loss is the area of this triangle here. So these are all of the sales that wouldn't happen, or that would happen if we had perfect competition, but don't. But what we need to do to find deadweight loss is we need to find the quantity under perfect competition. Right, and this is the quantity when price is equal to marginal cost. All right, so to do that, right, we can just set our inverse demand curve equal to the marginal cost. So inverse demand here is 100 minus P. Let me write this out. Sorry, 100 minus Q is equal to 20. Cost is 20Q, marginal cost is 20, right? And so we get Q is equal to 80. I'm gonna call this Q comp, and that's here. All right, so now, right, when we wanna calculate out deadweight loss, right, that's going to be the base of this triangle is 80 minus 40. The height of this triangle is 60 minus 20. Times 1/2 because it's a triangle. And that's going to get us deadweight loss of 800.